In the 1960s, military trainers had to step up their game to keep pace with the increasingly complex fighter aircraft. A tiny German company created a military trainer jet that wasn't really a jet. Meet the fan trainer, an aircraft that mimicked fighter jets but was powered by a ducted fan instead of a traditional jet engine. This unique design offered the agility of a jet with much lower operating costs, captivating aviation enthusiasts for decades, and now making a remarkable comeback. As fighter aircraft became more sophisticated and expensive in the 1960s, advanced military trainers followed suit. New planes like the Northrop T-38, the Mitsubishi T-2, and the SEPECAT Jaguar were developed to meet the rising demands placed on new pilots. These fledgling aviators faced a steep learning curve, moving from basic piston-engine trainers to advanced jet trainers, which created a notable capability gap. Addressing this gap became a priority, leading to the birth of a new class of jet trainer aircraft. Efforts to bridge this gap led to the creation of modern trainers like the Dornier Alpha Jet and the British Aerospace Hawk. Meanwhile, a modest German aviation company considered an alternative approach, aiming to design an aircraft that could blend the cost-effectiveness of basic trainers with the handling of a jet. Their goal was to smooth out the steep learning curve for novice pilots and simplify maintenance for air forces. The result was a classic tandem two-seat cockpit layout inspired by the Alpha Jet, but with a unique twist. Flugzeugbau, or RFB, a bold German company founded in the 1950s, started its journey with an original one-off pusher aircraft. Their next adventure led them into the realm of ducted fan propulsion, where they modified two gliders for flight tests. By 1970, RFB identified a gap in the market for an innovative trainer aircraft that could leverage its unique design approach. This vision gave birth to the Fan Trainer, a two-seat military trainer powered by a ducted fan. The mission was to create an aircraft with the agility of a jet, but at a fraction of the cost. The standout feature of the Fan Trainer was its ducted fan propeller located behind the cockpit, right in the middle of the fuselage. This strategic placement allowed the aircraft to mimic the flight characteristics of jet-powered trainers. Unlike traditional trainers with front-mounted engines, the mid-fuselage power plant gave the Fan Trainer handling qualities similar to operational jets, but at less than a tenth of the operating and fuel costs. While not as fast as jet trainers, the Fan Trainer offered novice pilots a genuine jet-like experience from the start of their flight training. The concept was promising, aiming to deliver realistic jet handling in an economically viable package. The RFB Fan Trainer gained attention for its unique mid-mounted ducted fan propulsion system, promising jet-like performance with much lower operational costs. Unlike the Dassault Dornier Alpha Jet, the Fan Trainer sipped fuel, using just a tenth of what its competitor did. RFB positioned it as an economical choice, claiming its procurement cost was a mere fifth of the Cessna T-37 Tweet. Despite these advantages, the German Luftwaffe wasn't initially sold on the idea. So, in 1973, RFB shifted gears to develop a civilian version, the RFB Fanliner, aiming to showcase the concept's potential and spark interest. The German Ministry of Defense eventually saw the value and backed the creation of two Fantrainer prototypes in 1975. By March, Flugzeugbau landed a contract from the ministry to build and test these prototypes. They were put through the paces as possible replacements for the Piaggio P149 trainers used by the Luftwaffe. Impressively, the first prototype was ready for testing in just 7 months. The Fan Trainer was all about making things efficient, affordable, and easy to handle. Pilots used to traditional turbojets would find its single-lever engine control system a breeze. The clever engine and fan setup had a movable turbine, demanding careful fan speed management. The British Dowty Group came up with a reduction gear that cut the engine's output by half, allowing the fan to spin at an ideal 3,090 revolutions per minute, which worked perfectly with its 5-bladed design and noise-canceling features. A foam plastic rubbing strip ensured precise clearance between blade tips and the shroud, enhancing performance. The fan's ring slot design guaranteed smooth airflow even at high power and low air speeds, adjusting asymmetrically to handle varied inflow during maneuvers. Structurally, the Fan Trainer had a metal box keel in the forward fuselage, providing flexibility for cockpit shape changes. The roomy cockpit was filled with extensive instrumentation and side consoles. mimicking operational Air Force aircraft with a nod to the Alpha Jet's design. Maintenance was a cinch, thanks to modular systems organized into detachable units. The forward-swept wing, inspired by the LFU-205 experimental aircraft, improved visibility by keeping the wing root out of the pilot's line of sight. Fuel efficiency came from integrated wing fuel cells, with adjustable wing length and advanced components like freeze ailerons and air brakes using state-of-the-art materials. The first ever flight of the initial prototype, tagged DEATJ, happened on October 27, 1977. This plane ran on two EA-871, 150 horsepower NSU Wankel engines, but these engines hit a few snags, requiring some tweaks. The second prototype, DEATI, switched things up with a single 420 shaft horsepower Allison 250 C20B turboshaft engine, taking its first flight on the last day of May 1978. Unfortunately, on September 7, 1978, the second prototype crashed, which led to significant modifications on the first one, upgrading it to the Fantrainer 400 standard. This included installing an Allison engine and improving the air intake system. Following the crash, the Luftwaffe put the Fantrainer under a magnifying glass, comparing it with the Beechcraft T-34C and Pilatus PC-7 turboprop trainers. Despite the Fantrainer being cost-effective, and some considering it the best option, the Luftwaffe stuck with the Piaggio P149. Nevertheless, Rheinflugzeugbau remained undeterred by the lack of a Luftwaffe contract. In May 1982, they revealed plans to start mass production of the Fantrainer within a few months. By this time, the prototype had notched up an impressive 500 flight hours, including a 5-week marketing tour across the United States, averaging 6.5 flight hours each day. Rheinflugzeugbau anticipated a market for around 5,000 trainer aircraft in the next 10 years. They set a realistic goal of capturing 4% of that market, translating to 200 aircraft, recognizing the Fantrainer's unique appeal. Enhancements were ongoing, and in 1983, the prototype received significant updates. The original 7-bladed ducted fan was swapped out for a sleeker 5-bladed version, meeting production standards. Cockpit upgrades reduced noise and improved visibility. Based on feedback from the Luftwaffe trials and other inputs, RFB decided to refine their Fantrainer to boost market appeal. This led to the creation of two main models, the Fantrainer 400 and the Fantrainer 600. The Fantrainer 400 ditched the twin Wankel engines for the more reliable Allison Model 250 C20 turbine engine, delivering 420 horsepower. The Fantrainer 600, on the other hand, packed a punch with the C30 engine, producing 650 horsepower, allowing a top speed of about 418 kilometers per hour and a flight time exceeding 4 hours. Both models featured modular production, sharing 92% of their components, which streamlined the manufacturing process. Despite these efforts, their success remains a topic of debate. The Thai Air Force was drawn to the idea of a versatile trainer and placed an order for 31 Model 400s in 1982 for primary training, along with 16 Model 600s for pilots set to fly the F-5E fighters. They also had the option to purchase 26 additional units. The Thai FT-600s had their cockpits modified to resemble the F-5E, complete with ejection seats. Initially, 2 units were produced in Germany, with the rest assembled in Thailand from kits. Deliveries started in 1984, and the aircraft were integrated into service by 1987. To better withstand the tropical climate, the Thai FT-400s were equipped with metal wings instead of fiberglass. This change, however, introduced complexity and led to deployment delays. The FT-400s also experienced operational issues and had a shorter service life compared to the more reliable FT-600s. Despite these challenges, the successful sale to Thailand encouraged RFB to explore additional marketing opportunities. One ambitious idea was to develop the Fantrainer 1000 for Paraguay, intended also to serve as a light attack aircraft. However, this project did not come to fruition, marking a setback for RFB. Despite this, RFB did not give up and aimed for a significant contract in West Germany during the mid-1980s, but this effort also faced difficulties. Faced with the harsh realities of the market, RFB pivoted towards developing jet trainers, teaming up with Rockwell International to join the U.S. military's JPATS program. This collaboration led to the creation of the Rockwell Ranger 2000, but it ultimately fell short of expectations. When RFB shut down in 1992, it somewhat cushioned the blow. As a result, the fan trainer's commercial prospects took a nosedive. Its limited service with the Thai Air Force came to an end as the geopolitical landscape evolved after the Cold War. The Thai Air Force turned to more budget-friendly surplus German Alpha jets, yet the fan trainer wasn't ready to be grounded for good. Against the odds, 3 of these aircraft stayed in operation, occasionally gracing European air shows and reminding aviation enthusiasts of its lasting legacy. Then, in a surprising twist in 2010, Fanjay Aviation acquired all rights and manufacturing equipment for the fan trainer.